If you work anywhere near business strategy or sales, maybe inventory management, you know the feeling. Data overload. Just drowning in sales records, transaction logs, customer info, and trying to manually spot a key trend and all that. Like noticing green widgets sell out weeks earlier in July, but only out west. That used to be, well, basically impossible. But now, AI is actually starting to solve this. Today, we're doing a deep dive into the sources, laying out the blueprint for this sales analysis revolution. We're looking at how companies are moving past basic charts to really use AI. Finding hidden profit drivers, getting a real edge. Okay, let's unpack this.
Yeah, our mission here is really to define that process. What are the actual steps? We're pulling together how you combine three key things. These AI copilots, unsupervised clustering algorithms, and then the visualization tools, all to get genuinely useful insights out of those mountains of data. The goal, really, across all the material is simple. It's about precision.
Precision.
Precision in your forecast, your inventory, your marketing plans.
Okay, so thinking about the flow. The first big challenge is just the sheer amount of data and getting through it fast. That's the AI foundation part.
Exactly.
We're talking AI copilots here, like Microsoft Copilot, MCP. The sources mention those. But this isn't just asking a simple question, is it?
No, not at all. It's about querying potentially decades of sales history across, dozens of different factors almost instantly.
So you, the strategist, could ask something complex like, analyze everyone who bought product A, then later bought product B, but segment that by age and regional climate, and get an answer in seconds.
That's the idea. And that speed, it's transformative.
How so?
Well, it cuts out that incredibly tedious back and forth that used to happen. The business leader asks a question, waits weeks for the data team. AI copilots just streamline that whole initial query phase. And maybe more importantly, they help kind of harmonize the data as they go, speeding up finding those initial trends that you need for the deeper stuff later.
Okay, but there's always a catch, right?
There is. And the sources really hammer this point home. Speed means nothing. It can even be dangerous if the data isn't clean. High-quality data is crucial.
Which brings us to ETL, extract, transform, load.
Exactly. The, let's call it the complex plumbing needed underneath everything else. The ETL pipeline.
Right. I want to dig into that because you hear that's where things get really complicated and expensive. Extract, transform, load sounds simple enough.
Yeah, sounds simple.
But what are companies really up against when they're trying to get that, 40% time reduction in data prep the sources mentioned? What makes it so hard?
You hit it on the head. It's not just cleaning up typos. It's more like structural engineering for data. Think about it. You've got sales data coming from your website, your store's point-of-sale systems, your main ERP platform, maybe even your shipping partner.
Okay, yeah, lots of sources.
And they all use different formats, different product codes, different ways of writing dates. Maybe one uses USD for currency, another just uses the dollar sign.
I'm here.
It's a constant, huge effort to make all those different systems speak one single structured language so the AI doesn't just, choke on inconsistent input later.
So the investment is high because you're basically building a universal translator for your company's data.
That's a good way to put it. Automated ETL is like the insurance policy. It guarantees the quality of the input for everything that comes after.
Gotcha. So the value isn't just saving time prepping data, it's actually avoiding making a huge multi-million-dollar decision based on like a bad date field or something.
Precisely. Risk mitigation.
Okay. So let's assume we've managed that. We've got the robust, clean ETL system running. Now we get to the analytical core, the part where the machine isn't just summarizing, it's actually discovering things. Here's where it gets really interesting. Clustering with unsupervised learning.
Right. This is really the engine room where the insights get generated. Clustering algorithms, often using popular tools like the Python library, scikit-learn. It's a type of unsupervised learning.
Okay, hold on. For listeners who aren't data scientists, what does unsupervised actually mean in this context?
Good question. It basically means we don't tell the system what groups or categories to look for beforehand. So in supervised learning, you might say, okay, here are 100 customers who bought this specific product. Go find me more people who look just like them.
Right. You give it the target.
Exactly. With unsupervised learning, you just feed the machine, say, millions of transaction records, and essentially tell it, find the meaningful groups that already exist naturally within this data. You don't tell it what meaningful means.
So it's finding similarities we might have totally missed.
Yeah.
Because we were only looking through our existing assumptions about the business.
That's the key. It identifies customer segments or detects sales patterns that might not be obvious at all, just by finding correlations across all sorts of different data points simultaneously.
Can you give a concrete example? Something traditional analysis might miss, but clustering would find.
Sure. The sources talk about seasonal spikes, but much more subtle than just summer sales up.
Mm.
For instance, the algorithm might flag that a particular group of customers, let's say self-employed people living in cities, they consistently buy a certain high-margin specialty coffee.
Okay.
But they only buy it in weeks where the average daily temperature falls between, say, 55 and 62 degrees Fahrenheit, regardless of the actual month on the calendar.
Whoa, that's specific. So it's a climate-driven behavior for a specific demographic.
Exactly. A pattern you'd likely only spot if you let the machine group transactions based on those kinds of hidden characteristics, not just time of year. And what's really impressive is the reliability the sources report. Pilot tests apparently showed these clustering algorithms can pull out insights like that with up to 90% accuracy, identifying those hidden patterns.
Okay, 90% accuracy. That sounds amazing.
Yeah.
But it also means 10% might be just noise.
Right.
Or even misleading.
That's a fair point.
If I'm a strategist and I'm betting real money on this data, how do I know I'm acting on the 90%, not the 10%?
Yeah.
How do you validate it before making a big inventory change or launching a campaign? Is there a safety check?
Yes, absolutely. And that's a crucial part of the process. It addresses that exact concern about trusting the machine too much. The sources are clear. That 90% reliability figure, it's achieved after visualization and after human review.
Okay.
The clustering gives you the raw mathematical pattern, but then an analyst, a human, still has to look at the visual output, the chart, the heat map, and apply their business knowledge, their common sense, to say, yes, this makes sense, or, this looks like an anomaly.
Right. Which brings us perfectly to that next stage, communication and validation. So we've queried the data with AI, found these clusters. Now, how do we make sure it's trustworthy and something we can actually act on? Visualization tools, you mentioned Matplotlib.
Exactly. Visualization is the critical bridge. It translates the complex math into something people can understand, and it acts as that quality control layer we just discussed. Once the data is queried and clustered, you use these tools to create interactive charts, maybe sophisticated heat maps showing how strong correlations are, detailed graphs broken down by segment. These visuals turn those dense data sets into clear, actionable insights. Makes it much easier for everyone involved, from the warehouse manager right up to the CEO, to understand what's going on and make decisions.
So it takes it out of the realm of pure data science and puts it right into business strategy.
Precisely.
And the sources, they give us actual numbers on the payoff for doing all this, right? This whole integrated system.
Yeah.
There was a 2025 study mentioned.
Yes, the quantifiable impact is really the headline result. Organizations that have successfully put this whole end-to-end process in place, the AI query, the clustering, the visualization, the validation, they've reported seeing up to a 25% improvement in sales forecasting accuracy.
25%. That's huge.
It is. And that improved forecasting ability connects directly to significant gains in operational efficiency.
Okay, let's try and make that 25% improvement more concrete, because it sounds massive. If a company normally forecasts, say, $100 million in sales for the year, and maybe they're usually off by 10%, that's a $10 million mistake, right? In tied-up inventory, or maybe missed sales or wrong staffing level.
Right. Big numbers.
So a 25% improvement on that error margin, that's like saving $2.5 million just from better forecasting. What are the main ways companies see those savings? Where does the efficiency come from?
It nearly always comes back to inventory and logistics. That's the big one. Instead of just guessing that summer sales mean a generic 3-month period, the clustering might reveal that, for example, demand for a key part of a seasonal item spikes 3 weeks earlier in the Pacific Northwest than it does down in the Southeast.
Ah, okay. That level of detail.
That precision lets the company drastically cut down on holding costs. You know, the cost of just storing inventory for those 3 weeks where they used to hold it unnecessarily. And they can shift that stock or production focus immediately to where the demand actually is. So they're not stuck with warehouses full of stuff that isn't selling yet, and they're not running out of the hot items in the places where people want them now. It's about syncing the supply chain with the real customer behavior that the AI helped uncover.
That operational timing.
Sure.
Yeah, I can see how that delivers a real competitive advantage.
That's the core of it.
Okay, this whole system sounds incredibly powerful, but we did touch on the complexity earlier. If a business is listening and thinking, okay, I want to move from my basic spreadsheets to this, what are the biggest roadblocks they're likely to hit today?
Yeah, the sources point to 2 main hurdles, as we sort of hinted at. The first one, and it's always there, is just maintaining that consistent data quality.
Back to ETL again.
Always back to ETL. That pipeline isn't a one-time build, it's a living system. If just one of your data sources changes its format or API, suddenly the accuracy of your clustering results can plummet. Data quality is a continuous effort, a constant battle.
Not a set it and forget it thing.
Definitely not. The second big challenge is that initial investment. Setting up the ETL infrastructure properly, getting the licenses for the right tools, maybe hiring people with the specialized skills needed. It's a significant barrier to entry.
So does that mean this is really only feasible for the huge Fortune 500 type companies right now? Or are there ways for small businesses to get in on this too?
Well, the good news is the solution landscape is changing fast to tackle that cost barrier. The sources really emphasize using cloud-based solutions.
Okay, scalability.
Exactly. Cloud platforms offer scalable options. You can start smaller. It makes this kind of powerful tech much more accessible for businesses of different sizes. It shifts that potentially huge upfront capital cost into a more manageable operational expense.
That makes sense.
But the core rule still applies. If you scale up your data inputs, you absolutely have to maintain or even improve your data quality standards. More data just means more potential points of failure if it's not clean.
Right. Garbage in, garbage out, just on a much bigger scale. Okay, that gives us a pretty clear picture of how to approach this today. But looking forward, if this is the level of precision we're getting now, what does this mean for the future? For business analysis, and maybe even for us as consumers?
We should definitely expect this integration to get even tighter, even deeper. AI models keep improving, visualization tools get more sophisticated. We'll be able to pull even more complex insights from even larger data sets. We're likely moving beyond just purchase history and demographics into maybe predicting behavior based on analyzing unstructured data too, like text or images.
Wow.
The overall direction seems to be towards, well, hyper-personalization. Businesses are going to rely more and more on this combination, the smart AI query, the deep clustering analysis, the clear visualization to create sales strategies that feel incredibly tailored to each individual.
Which should improve customer engagement, presumably.
Will radically improve it, potentially. And that really cements the competitive advantage, making this integrated approach pretty much indispensable for any company that wants to stay ahead of the curve.
That wraps it up perfectly. We've walked through the three key pillars, changing the game in sales analysis. You've got the AI copilots making querying faster and helping clean the data. Then the clustering algorithms doing the heavy lifting, uncovering those hidden patterns with, surprisingly high accuracy.
Up to 90%, yeah.
And finally, the advanced visualization that makes those insights trustworthy, actionable, and leads to those big improvements, like that 25% bump in forecasting accuracy. This is really how smart companies are shifting from just managing data overload to actually extracting real growth from it.
And maybe, just to leave you with a final thought, if we connect this to the bigger picture, it raises a really interesting question for you, the listener, as a consumer. Think about it. If AI allows companies to understand not just what you bought, but potentially why you bought it, pinpointing your specific triggers, whether they're emotional, regional, seasonal, with that kind of 90% accuracy, how are our own expectations for personalization going to change? Across every single interaction we have with any business, that level of deeply tailored experience is coming. What will you start to demand next when every company seems to know exactly what you need, maybe even before you ask for it yourself?